Hello, before we get into the video, let me introduce my name. My name is Veneranda Bibi Filatio. Special thanks to Miss Anna Fitriana SEMM as our lecturer for Economic and Businesses. This is our presentation about equation that based on the derivative function for the economic use.
This video is brought to you by MUS. The members are Mary Andani, Veneranda Baby Fiolatio, Charlie, and Rian Hidayat. We will explain about manufacturer advantage, joint product, price discrimination, production function, partial elasticity, multiplier number, and we will give both example and practice question.
Okay, now explain about produce advantage. The purpose of produce in the producing goods is the considered to be to obtain the maximum profit. The conditions that must be met for goods to generate maximum profit are input price MP equal open brackets PX open brackets, output price open brackets PQ close brackets. Example 7, if the producing function of the company is now to produce output.
And the example are, if the total revenue the producer got is TR equals to 200Q minus 5Q square, and the total cost is TC equals to 40 plus 20Q, find the total output that should the producer supply to get the maximum profit. So the profit is the maximum if the marginal revenue equals to marginal cost, MR equals to MC. So to find the marginal revenue is derivative of total revenue respects to Q or quantity. So TR equals to 200Q minus 5Q square, and MR equals to 200 minus 10 square. So remember, it is derivative. So MR is a derivative of TR. So it is 200 minus 10Q. As for the marginal cost, is the derivative of total cost. That is TC equals to 40 plus 20Q. That means the marginal cost is 20 because it is the derivative of total cost. So the quantity that needs to be produced to get the maximum profit is MR equals to MC. So 200 minus 10Q equals to 20. That leaves us to 180 equals to 10Q, and that gives us Q equals to 18. And this is the maximum profit because we bring it to the second derivative. It is smaller than 0, and if it is smaller than 0, that means it is maximum profit. If it's bigger than 0, then it is the maximum loss.
So for this part, I'm gonna explain to you guys about the joint product. It was simply work of two or more products that are equally the same important to produce, which it simultaneously from the same processes with each of having a significant relative sale value are known as the joint product. For example, in the oil industry, there is gasoline, fuel oil, lubricant, paraffin, coal tar, asphalt, and the kerosene that are all of those produced from the crude petroleum, which these are also known as the joint product. The commonly used method for apportioning of the total process cost up to the point where the separation over the joint product are also followed. There is one method that it can be used, which is the physical unit method, where this method is based on the assumption that the joint products are capable of being measured of the same unit. Accordingly to the joint cost, here are the apportioned of the bases that some physical base such as weight, numbers, and etc. In other words, the basis that used for apportioning the joint cost over the joint products is the physical volume of the material that present in the joint products at the point of the separation. Any losses arised during the joint production process is also apportioned over the product on the same basis. This method cannot be applied if the physical unit of the two products are different. The main defect of this method is that it gives you the equal importance and the value to the all joint product. In simple case, where there is the only one kind of the input that used to produce two kinds of output, the producers face two kinds of demand curve, which is supposed to be the output of goods A and goods B, where it's supposed to be QA is for amount of item that A produce, while the QB is the amount of item B that it produced. Then the demand function that facing by the producers, it was PA equals to FQA, and for the PB it was F for QB, where the PA it was the price of goods A and the PB is the price of the goods B. Joint cost, namely cost incurred by the producers to produce both type of the goods that can be shown by the function of TC equals to G open bracket QA and QB close bracket. Then where the TR is the total revenue, so the profit is TR subtract the TC, where TR equals to PA times QA plus PB times QB. And for the last one, the purpose of the producers here is to find out how many level of output that must be produced so that the profit it was maximized, where the equation it was the P it equals to PA times QA plus PB times QB minus G open bracket QA and QB close bracket.
And for the joint production, if a company produces two kinds of products and the request function is Q1 equals to negative P1 plus 26 and Q2 equals to negative 1 by 4 P2 plus 10, and the cost of joint production is C equals to Q1 square plus 2Q1 times Q2 plus Q2 square. Find the quantity of product 1 and 2 that should be supplied to have a maximum profit. And what is the maximum profit? The first thing to do is we need to transpose the formula from where we got Q1 and Q2. We need to find the P1 and P2. So here we have Q1 equals to negative P1 plus 26. We're going to transpose it, becomes to P1. And this leads to P1 equals to 26 minus Q1. Earlier P1 is negative, but now it is the Q1 is negative. And we did the same thing to the Q2. So Q2 equals to negative 1 by 4 P2 plus 10 transpose to P2 equals to 40 minus 4 Q2. The 10 becomes 40 because we times this formula with 4, and the Q2 also becomes 4Q2 because it is times with 4. This happens when we transport the formula when we put the P2 in the left side. So the revenue formula is P times Q, where we're going to look for the revenue 1 and 2. Then we could look for the total revenue for both products. So R1 equals to P1 times Q1. So P1 is 26 minus Q1, and Q1 we're just going to put it as it is. So 26 minus Q1 times Q1 equals to 26 Q1 minus Q1 square. And revenue 2 is also the same, so P2 times Q2, so it is 40 minus 4Q2 times Q2, so it is 40Q2 minus 4Q2 square. To find the total revenue, we could add the first and the second revenue. So we're just adding them up. It becomes 26Q1 minus Q1 squared plus 40Q2 minus 4Q2 squared. Now we're going to look for the profit, and how we do it is the total revenue minus total cost. Since we already find out the total revenue and the total cost is in the question, so we could just put it in. So P equals to R minus C. So 26Q1 minus Q1 squared plus 40Q2 minus 4Q2 squared. So that's in the brackets, and then we minus it with another in the bracket, that is Q1 squared plus 2Q1 Q2 plus Q2 squared, and it gives us negative Q1 squared plus 26Q1 minus 2Q1 and Q2 plus 40Q2 minus 5Q2 squared. Then we're going to find the derivative. So we do this with the partial derivative, where we're going to focus on one function and then we could focus on the other one. For the scenario, we could focus on Q1 and Q2. First, we're going to look for the first Q or Q1. The derivative of negative 2Q1 squared plus 26Q1 minus 2Q1 Q2 is negative 4Q1 plus 26 minus 2Q2 equals to 0. Next, we're going to focus with the Q2. So the derivative of the negative 2Q1 Q2 plus 40Q2 minus 5Q2 squared. Remember, we focus on the Q2. So the answer is negative 2Q1 plus 40 minus 10Q2 equals to 0. Now we're going to find the value of Q. So what we're going to do is negative 4Q1 plus 26 negative 2Q2 equals to 0, and negative 2Q1 plus 40 minus 10Q2 equals to 0. So I'm going to look for the first for the Q2 first. That's why we times negative 2Q1 plus 40 minus 10Q2 equals 0 with 2 to erase the negative 4Q1 to erase the Q1, and we could find the Q2. So when we minus it, we got negative 54 plus 18Q2 equals to 0. And this is where we make it 18Q2 equals to 54, and we find it the value of Q2 is 3. To find the Q1, we could find it from the function that we have made, and we could input the 3 into the Q2. At both functions, we could choose whether the first or the second function. I'm going for the second function. That's why negative Q1 plus 40 minus 10Q2 equals 0 becomes negative Q1 plus 40 minus 10 times 3 equals to 0. And we could get negative 2Q1 plus 10 equals 0, and it becomes 2Q1 equals 10, and we get the value of Q1, that is 5. So the profit will reach the maximum if Q1 and 5 is 5 and the Q2 is 3. To find the value of the maximum profit, we can input the Q1 and the Q2 into the profit function, if you remember. So it is negative 2Q1 squared plus 26Q1 minus 2Q1 times Q2 plus 40Q2 minus 5Q2 squared. So when we input that, it becomes negative 2 times 5 squared plus 26 times 5 minus 2 times 5 times 3 plus 40 times 3 minus 5 times 3 squared. So that equals to 125. So the maximum of profit value is 125.
Price discrimination. At a monopoly market, monopoly can just up the price by selling its goods in several places at different price of sale. The case will be discussed. Here is a circumstance in which the manufacturer deals with two different files and the buyers cannot purchase the product at one market to sell in the other if a monopoly applies discrimination on price to different two markets. The advantage is a discrepancy between the total demand of two and the total cost of production. Example, with a monopoly against the two markets of A and B, whereas TRA in parentheses key A and TRB in parentheses key B is the total acceptance from the market A and B, And the total cost of production for the good sold in both market is TC in parentheses KI plus KB, then the profit. V equal TRI in parentheses KI plus TRB in parentheses KB minus TC in parentheses KA plus QB. In order to maximize profits, then first order requirements delta V for delta KA equals TR action A in parentheses KA minus C action in parentheses KA plus QB equals 0. Delta V for delta KB equals TR action B in parentheses KB minus C action in parentheses KA plus KB equals 0. So TR action A in parentheses KA equals TR action B in parentheses KB equals C action in parentheses KA plus KB, whereas TR action A in parentheses KA is marginal admission in parentheses equals MRA. MRA in market A and TR action B. TR action B in parentheses KB is marginal in parentheses equals Mr. MRB in market B, whereas C action in parentheses KA plus KB nothing short of the cost of marginal in parentheses MC. So it turns out that in every market MR equals MC. From here can be calculate the amount of production to be made in order to generate maximum profit and for unit price to be stabilized in each market.
So the example for price discrimination, there's a producers that have a chance to do discrimination in price between first market and second market. The demanded product is this. So Q1 equals to negative 0.2 P1 plus 16, and Q2 is negative 0.5 P2 plus 9. And the total cost of produce both product is C equals to 50 plus 20Q. And what is the maximum of profit if the producer do the discrimination in the market price? Because it is discrimination to the price, that means P1 is equal to P2. Keep in mind, we're going to transpose the formula like earlier we did in the joint product. So Q1 equals to negative 0.2 P1 plus 16 become P1 equals to negative 5Q1 plus 8T, because we need to get lost the 0, so we times it. And Q2 equals to negative 0.05 P2 plus 9 becomes to P2 equals to negative 20 Q2 plus 180. Next, we're going to find for the total revenue. So the first revenue is P1 times Q1. So it is negative 5 Q1 plus 8T Q1 times Q1, and that gives us to negative 5 Q1 square plus 8T Q1. For the second revenue is P2 times Q2. So that is negative 20 Q2 plus 8T times Q2 equals to negative 20 Q2 square plus 180 Q2. And for the total revenue, we just add them up, and it gives us negative 5 Q1 square plus 80 Q1 minus 20 Q2 square plus 180 Q2. So the cost we turn into C equals to 50 plus 20Q equals to 50 plus 20, because the Q is actually Q1 plus Q2. So it is 50 plus 20 Q1 plus 20 Q2. Next, we're going to find for the profit. And remember, profit is revenue minus cost. So P equals to R minus C, and that is negative 5Q1 squared plus 80Q1 minus 20Q2 squared plus 180Q2, and that's in bracket. We minus it with the cost, so that is 50 plus 20q1 plus 20q2. So it gives us negative 5q1 squared plus 60q1 minus 20q2 squared plus 160q2 minus 50. Next, we're going to do a partial derivative because we need to find both q1 and q2. So first we're going to focus on the private q1. That is negative 10q1 plus 60 that equals to 0. And then we could find the value of the q1 because we just need to shift it. So q1 is negative 10q1 plus 60 equals 0. That gives us q1 is 6. And for the pq2 equals to negative 40q2 plus 160 equals to 0. So the value of q2 is negative 40q2 plus 160 equals to 0, and q2 is 4. To check if the maximum is just we need to derivative of the pq1 and the pq2, and we times it when we got the bigger than 0. That means it is maximum, and this is maximum. So we just need to input the q1 and the q2 value to the profit formula, and that is negative 5 times 6 squared plus 60 times 6 minus 20 times 4 squared plus 160 times 4 minus 50, and that is equals to 450. So
Production function. The producer in the production of goods has a technical basis, which in economic theory is called production function. The production function is a subfunction or equation that shows the relationship between the output level and the use of input level. In general, production function could be written as Q equals F in parentheses x1 point x2 point x3 point xn, where Q shows the magnitude of the output and x1 point x2 point x3 xn is the input used. The key brand output is also called a total physical product, and this TPP. The TPP curve is defined as a curve that shows total production level in parentheses key on different level of variable input used and other input is stabilized. So TPP equals key equal f in parentheses x point x1 point x2 point xn. Another curve that can be derived from the TPP curve is the marginal basic product curve, abbreviated as MPP, and the average physical product curve, abbreviated as AF. The marginal physical product in parentheses MPP is a curve that shows the additional TPP due to the use of an additional unit of input variable.
So for the example of production function, it is known the production function is z equals to negative 2x squared plus 5xy minus 3y squared. So find the productivity marginal of x and y, and so the x marginal productivity is just the derivative of z, but we focus on x, and that is zx equals to negative 4x plus 5y. And it is the same for the y marginal productivity. We have the derivative of the production function with the partial derivative. We only focus on the y, so zy equals to 5x minus 6y. If you remember, we bring down the power of number and then we times it with the variable, and then the power of number is minus, so it gives us with zx equals to negative 4x plus 5y, and zy equals to 5x negative 6y.
Hello everyone, my name is Mary Andani. I here will explain about partial elasticity. Okay, what is partial elasticity? What is meant by partial elasticity of a demand factor is discussing demand that is influenced by several factors. Factors that were previously considered fixed of ceteris paribus were removed. That is, they did not consider the price of the good and income to be fixed. Then the general form of the request function is the follows. Q equal A minus BP, plus CP, plus DY, where Y equal income P2 price of substitute goods. P1 equal price of good, open brackets, Q close brackets. From the demand equation above, two cases of elasticity can be found, namely income elasticity and cross elasticity. Income elasticity, open brackets, AY, open brackets, measure the percentage change in the amount of good demand due to the 1% change in income if the often variable do not change. Mathematically written, Fy equal D partial Q D per D partial Y dikali Y per Q V, or D equal Q V per D partial Y dikali D partial Q V per D partial Y. Cross elasticity, open brackets, ES, open brackets, measure the percentage change in the quantity demand of a good due to a 1% change in the price of often good. While the often variables remain constant.
And the example for partial elasticity, their demands for chicken meat, the function is Q1 equals to 2,500 minus 5P1 plus 3P2 plus 0.2Y. If Q1 is the quantity of chicken demanded and the P1 is the price of the chicken, and P2 is the price per unit of cow meat, and Y is consumer profit, and if Y equals to 7,000 and P1 is 100 and P2 is 200, find the elasticity revenue. So what we're going to do is Q1 equals to 2,500 minus 5P1 plus 3P2 plus 0.2Y. We input the data in the function and we could count the function. So Q1 2,500 minus 5 times 100 plus 3 times 200 and 0.2 times 7,000, and this gives us to 2,500 minus 500 plus 600 plus 1,400 equals to 4,000. Next, we need to find the partial derivative function of Q1 respects to Y. Because it is partial, we focus on Y, and that means Q1 derivative respects to Y is 0.2. If we want to find elasticity, that means the derivative of Y we times with Y and divide by Q1. That gives 0.2 times 7,000 per or by 4,000, and the answer is 0.35. This means the customer revenue increased 1% and then the demand of cow meat increased in 0.35% when the price of both cow and chicken meat is just the same. This happens when a person wants to eat something that they rarely eat because they have more money now. Multiplier number. So what is multiplier number? A multiplier is a coefficient of or a number that can explain the amount of additional national income as a result of additionals on certain variables in the economy. Since Y is affected by CIG, TX, TR, XN, then there will be a multiplier. Consumption multiplier is a number that shows the amount of change in national income due to changes in consumption by 1 unit. So we write it as AY by AC. And the multiplier itself has several forms such as government spending, taxes, investment, and so on. We know MPC and MPS. MPC equals to AC by AY, MPS equals to AS by AY. C is cost, S is additional saving, Y is the additional income. Keep in mind that MPC plus MPS equals to 1. The example for multiplier, if there's a revenue or it is Y that is 170 and a consumption that is C that is 150 and investment that is I that is 20, if there is an addition in an investment as much as 10, how much is the total revenue Y derivative if the amount of living is 0.6? So we need to find the derivative of Y, and this is y derivative equals to c plus I plus differentiation of y. To find the differentiation of y is we need to search for the differentiation of I times with 1 by 1 minus the k. So it is 10 times 1 by 1 minus 0.6 equals to 10 by 0.4, and that is 25. So we could find the derivative of y, and that is y derivative plus c plus I plus the other y. So it is 150 plus 20 plus 25. And the answer of the total revenue of derivative y is 195.
So for this last part, I'm gonna explain how the way to solve academic equation that based on the derivative function. So for the first example, we have to determine those amount of time that it needs for the maximum cost it takes. So for the cost per hour, the equation, it was 4x minus 800 plus 120 divided by x. So for the fx itself, we have to times it with the amount of hour. So 14x minus 800 plus 120 divided by x times open bracket x. So every of the equation from the cost per hour will divide it by the x. So it remains 4x square root so it remains 4x power of 2 minus 800x plus 120. Then for the minimum cost, it was for the f-accent. Then for the minimum or the fx accent, it was 8x minus 800. Don't forget, with the equation of fx accent, it was 0. So the equation is 8x minus 800 equals to 0. Then it lasts for the x, it costs 100. Then the time that it needs for the minimum cost it takes is 100 hours. So for the second example, we have to determine those maximum profit of its company, which it produce the amount of X product. So the way how we do it is we have to determine those fx. It was the cost per product, and it was 9,000 plus 1,000x plus 10x power of 2, and the amount of product that it sold is 5,000x. For the profit equation, it was the total revenue minus the total cost, where the total revenue it was 5,000x, and for the total cost it was the function of the cost per product. It was 9,000 plus 1,000x minus 10x power of 2. So the fx it was minus 10x power of 2 plus 4,000x minus 9,000. For the fx accent, it was the derivatives of fx, so it remains minus 20x plus 4,000. Don't forget the fx accent, it was 0, so minus 20x plus 4,000 it was 0, so it remains x it was 200. So for the maximum profit of the company, if it produced 200 product, it was f of 200, it was minus 10 times 200 power of 2 plus 4,000 times 200 minus 900, then it remains 3,000. Then it remains 391,000. And it remained 391,000 rupiah. For the third example, we have to determine those maximum profit, which it from the question itself, it already says the function of quantity demand. It was minus 0.25p plus 6, which we have to find those P equals 2. So 0.25P equals to 6 minus Q, where the P, it remains 24 minus 4Q. For the total revenue itself, it was the function of P times Q, where the P is 24 minus 4Q, then times the Q, so it remains the total revenue. It was 24Q plus 4Q square of 2, power of 2. For the total cost, it was Q times the cost of each unit. For the Q itself, it was Q, and the cost of each unit, it was 4. So for the total cost is 4Q. And for the almost last one, it was profit. So the way how we find those profit, it was total revenue minus the total cost, which the total revenue, it was 24Q minus 4Q power of 2 minus 4Q, which it remains the equation of profit. It was 20Q minus 4Q power of 2. For the next one, we have to find it again, which it was the P accent or the FX accent. It was 0, so don't forget 20Q minus 4Q power of 2, it was the derivatives. So we have to also find those derivatives of those profit equation, or we can say it was the P accent. It was 20 minus 8Q. So don't forget, it was the FX accent. It was 0, so it remains 0 equals to 20 minus 8Q. So we already find those profits. So we're gonna find those derivatives of equation from the profit. It was 20 minus 8Q, which don't forget the FX accent, it was 0, so it remains Q equals to 2.5. For the P, don't forget, it was 20Q minus 4Q power of 2. So for the P maximum, it was 20 times 2.5 minus 4 times 2.5 power of 2. So it remains 39.4. So the maximum profit that it got, it was 39.4. So for the fourth example, we have to find those function of profit, which it already shown at the question. It was the function of quantity demand. It was minus 0.5p plus 3, which the cost of each product, it was 1.5. Then from the function of quantity demand, we have to find those p equals to, so we can change those direction into 0.5p equals to 3 minus q, where the p equals to 6 minus 2q. Then we have to find those total revenue. It was p times q, where the p is 6 minus 2q times the q. So it remains the total revenue function is 6q minus 2q power of 2. For the cost per product itself, it was 1.5. So for the CT, it was C plus T, where the C itself, or the cost itself, it was 1.5 plus 0.5, which it remains 2. For the CT itself, it was Q times CT, where it was Q times 2. So it remains of the CT, it was 2Q, where the next one, it was the function of profit. So the function of profit, it was also the same as the FQ, or the profit, it was equals to total revenue minus of the CT, where the total revenue, it was 6Q minus 2Q power of 2 minus 3Q, where it remains the function of profit. It was 3Q minus 2Q power of 2. So for this last example, we have to determine those maximum profit that this company get. So from the equation itself, it already determined to us that it was the fx, it was 55 minus half of the x. And for the cost for each part, it was 1/4 of the x power of 2 plus 25x plus 25. So the function of profit, it was total revenue minus the total cost, which from the total revenue, it was 55x minus half of the x power of 2, where plus the total cost, which it was 1/4 of x power of 2 plus 25x plus 2, where the total of the fx, it was minus 3/4 of the x power of 2 plus 30x minus 25, where the maximum profit, we can find it with the derivatives of fx, it was minus 3/2 x plus 30, where don't forget the fx accent, it was 0, so the x remains 20, and we enter to the fx, it was minus 3/4 times 20 power of 2 plus 30 times 20 minus 25, so it remains 275. So the maximum profit that it got from this company, it was 275,000 rupiah. So that's all for our equation that based on the derivative function for the economic use. Thank you and goodbye.